Let's consider exponential functions. An exponential is anything which has the form 2 to the x or 3 to the x. In general, a number, a constant, to the power of x. So let's see what these graphs look like. Y equals 2 to the x. Let's just think about how we would plot those. First of all, let's find a y-intercept. Let's set x to 0. 2 to the 0 is 1. So we know our graph is going to cross the y-axis at 1. And now let's consider what happens as x gets larger. So just like when we was considering other graphs, we consider behaviour as x gets very large and x and y intercepts. So for large x's, we're going to have 2 to a large power. That's going to become very large very quick. 2, 4, 8, 16, 32. It grows very quickly. Okay, so we've got our y-intercept. Can we get an x-intercept? Is there a number such that 0 is equal to 2 to the x? Well, no. There's no number of 2's we could multiply together, if we think of exponentials still like that will give us 0. So we don't think there's going to be an x-intercept. But let's think what happens when we start putting in negative numbers in here. We remember that negative powers, so let's imagine minus 2, would mean 1 over 2 squared. So what's going to happen as we start putting in larger and larger negative powers? We will get larger and larger reciprocals. 2 to the power of 5 is 32. So this number is going to get smaller and smaller and smaller. We will have an asymptote at y equals 0 because there is no number that we can divide 1 by to get 0. Similar to how we had asymptotes on the graph of y equals 1 over x. Doesn't matter how big a number we divide by, there will always be some positive y value there. Okay, so what can we tell looking at this graph? First of all, we know that this is an increasing function. We don't know how to differentiate this yet, and we won't learn until next year, but we can tell already it's an increasing function. It has a y-intercept of 1, and it grows very large. Equally, it reduces to a very small number, but that will always be a positive number. It never crosses 0. Okay, so we've got the graph of it. What else do we know about exponentials? Well, we can plot the graph of y equals minus 2 to the minus x by just considering what we know about this. We could consider this, if this is the function of fx, this would be the function of f of minus x. From our knowledge of transformations, we know that is a reflection in the y-axis, as all it's doing is it's swapping the x's for negative x's. So this would be the graph of y equals minus x. Okay, so we've met our functions and we've learnt how to study what happens in long-term behaviour. So as x increases for this graph, so f of x, if we consider the limit as x goes to infinity, this function will tend towards infinity. What happens in this case? Well, if minus x tends towards infinity, so the limit of minus f of x as x goes to infinity, this will be 1 over larger and larger numbers, so this will tend towards 0. Okay, as x gets larger and larger, in this case we go to 0, negative x values. In this case, for large positive values, we go off to positive infinity, crossing at 1. So we understand its behaviour and what will happen in the long term as we go into large negative numbers, and in the long term as we go towards large positive numbers. Next, we'll consider how to undo these exponentials.